Okay, let's look at number 8 in your Agile Mind book on page 111. So we have here another logarithm that we need to condense before we can switch it to exponential form. So we have addition here that's going to become multiplication. So when we do that and multiply those two arguments together, we're going to wind up with log base 6 of x plus 5, that first argument, times that second argument, x minus 4. And that still equals 2. That's not changing. Then what we're going to do is we are going to multiply those together. We're going to simplify inside this logarithm here and multiply them together. So what we're going to have is log base 6 of, and you can either do this in the box and you can do it off to the side like here and multiply it through the box, or you can use your distributive method. Either way, we're multiplying x plus 5 times x minus 4, using our box the other direction than we've been doing lately, to get our x squared, 5x minus 4x and minus 20. And then we're going to simplify this by combining our like terms. Ooh, that circle's weird, but that's okay. We'll see it. And bringing it out of the box to our x squared. Positive 5x minus 4x gives us plus 1x minus 20. And that's going to still equal 2. Now that we have the logarithm condensed and simplified, we're going to switch this back to our exponential form. So we are going to have our base, our power, and our argument. And we are going to reset this into exponential form. So we're going to have 6 squared, there's our base and our exponent, equals our argument, x squared plus 1x minus 20. And then we're going to try and solve for x now, because when we're solving, we're trying to get an x equals. Well, now I have a quadratic, and I'm trying to get to an x equals, which means I need to factor again. So first things first, I need it to equal 0. So I'm going to simplify the 6 squared to be 36 equals x squared plus 1x minus 20. And then what we're going to need to do is subtract 36 from both sides to get it to equal 0. So now I'm going to build this wall, and we're going to go back up to the top, and we're going to wind up with 0 equals x squared plus 1x minus 56. And we're going to factor this because we need to get our solutions, our x equals. So we're going to go ahead and put this through our x and our box to factor it. So we have our a times c at the top and our b on the bottom. A times c, a being the 1, c being the negative 56, we get negative 56 on the top, and our b on the bottom is a positive 1. Now, since our top number is negative, that means we're going to have one positive, one negative number in our frame, and we're looking at our differences in our factors. So I need products or numbers that multiply up to be negative 56 and add to be a positive 1, so they need to have a difference of 1. So what I think of when I see that is we're going to wind up with 8 and 7. They multiply to make 56 and have a difference of 1. And if I want this to be a positive 1 on the bottom, I'm going to need this 7 to be negative. That way we wind up with a product that is negative and a sum that is positive. So then we're going to fill in our box. So we have our x squared and our minus 56 from our original equation. And then those two numbers from our x frame tell us how to split this variable. So we're going to have our 8x and our minus 7x. And then we're going to pull our factors to get this into our factored form. So we're going to have x and minus 7, x and positive 8. Putting this into our factored form, we're going to have that our 0 equals x minus 7 and x plus 8. Remember, we're still trying to get to an x equals our zeros or our roots or our solutions. So we're going to set each of these factors equal to 0 to find our solutions. So we'll have our x minus 7 equals 0 And we'll have our x plus 8 equals 0. Solving each of these, we get that x equals positive 7 and x equals negative 8. But we can't stop there. We need to take these solution options and double check that our factors, or that our arguments, are going to be positive. They need to be positive. I don't care what their values are, they just need to be positive for it to work. So if I substitute in 7 for both of these x's, 7 plus 5 is definitely positive, and 7 minus 4, that's a positive 3, so that's positive. So x equals 7 is a valid solution. Then I'm going to do that same check with our minus 8. Negative 8 plus 5 is negative 3. So this argument is going to be negative, which that alone is enough to make this extraneous. Extraneous. With this x minus 4, if I substitute in my negative 8 minus 4 is also negative. So this argument also doesn't work. So our x equals negative 8 is extraneous and our x equals 7 is valid.